right now I've created our cylinder a height of 80 and radius of 22, whatever that unit is. One of the cool things about 3D Studio is that you can go to customize, and you can do go to unit setup, and you can set your display unit to something else. You can set it to metric, you set it to meters if you like, you can set it to US standard, and so you can do feet with fractional inches, or feet with decimal inches. This is a really interesting one, this feet with fractional inches, because it allows you to actually write down, 6 foot 1 1/8 or whatever. And so, it's kind of cool that you can do that. It can get annoying typing those numbers. I'll normally work in, truthfully, I'll normally work in generic units, but if I happen to want to work in an actual unit, I'd more likely go with metric. But we're in the US here. Well, guys can download from anywhere, I guess, so not necessarily. But anyway, I'm going to use feet with fractional inches because we're going to be working on a telephone pole, and I happen to know how big a telephone pole is in feet and fractional inches, so I'm going to specify it that way. Plus, just because it's kind of interesting that you can do that. Most 3D software works in generic units and doesn't really allow this kind of flexibility that 3D Studio does. Anyway, you can also work in furlongs if you really want. This FL, that actually means a furlong, which is 660 feet, which you can create a custom unit if you have some world which demands it, or you're potentially who uses furlongs anymore, railway workers in England, maybe. I think they still specify things in furlongs typically. Anyway, but so you can again, probably not going to be very handy to you. Again, so we're going to work in US standard. I'm going to hit OK, and you'll see it actually already converted my radius and my height into feet here. So we've got a cylinder. As I said, I'm going to make a telephone pole, which I happen to know, if I go under Modify, is, it's about, let's see here, you can see the 6 foot 8 and 24 seconds. Well, that doesn't round very good, does it? But anyway, it's in 30 seconds. So it's, let's make this a radius of 6 inches. So give it about a foot wide here, and we're going to do a height of 40 feet. So you're actually typing it in inches and feet. So 6 inches, 40 feet. You can find that out if you are dubious. Could be 30 feet if you look up. Internet's a wonderful place, right? So if you Google telephone pole height. Looks like a lot of people Google that. There's a suggestion. How tall is first one? How tall is a standard telephone pole? Well, let's see what Yahoo Answers says. Well, it says that here's a pole line constructor. Says that used to come in 30, 60, and 90 feet, and a third of it is buried in the ground. So telephone poles are either 20, 40, or 60 feet high. All right, so we know if I have a 40-foot one, well, let's make it a 30-foot one. So our dimensions aren't too exaggerated. We'll make it a little shorter one. Great, so we have we know this is the right size now for a telephone pole. One of the handy things about working in real-world dimensions, though, is that if you do, you can get your relationships right. It's easy. It can be easier to get relationships between sizes of things correct. So in this case, the relationship between the size of the crossbars and the actual pole can be correct. And then we add some other stuff in here. We know it's the correct size. Because sometimes you're like, why does it not quite look right? Well, if you know it's the correct size, then it pretty much should, right? All right, so we take this telephone pole, and one of the things I'm going to do is telephone poles do taper. I'm going to call this, or I'm going to go over here to the modifier selection, and you can't see it, but I'm going to choose taper down there on the very end. And then I'm going to taper that by an amount of negative 0.35, not quite half its height, or half its radius at the top, or a little more than half rather. So you get a little bit of taper. Now the next thing I'm going to do is I'm actually going to go back to that original cylinder. Again, the power of the stack. So I'm going to go back to the parameters of the original cylinder, and I'm going to look at what I've got here. So I'm going to maximize this view. I have several divisions this way. So I just have, what do we have here? 5. I have 5 divisions this way. What I'm going to do is I want to add a little bit of variance to this thing. I don't want to noise it up too much, but I'm going to noise it up a little bit, meaning just going to give it a little imperfection. So if I'm going to do that, I'm going to need a few more height segments. I might even want more than that. So give it a few more height segments, and then I'm going to go into the modifier list, and I'm going to give it noise. Now, this noise modifier we looked at before, but anyway, now even the noise modifier shows up, the strength shows up in inches. So this is the maximum displacement in X here in inches and feet. So if I look at this, you can sort of see what it's doing. You can see that it's giving me a maximum displacement there of, what do we got, 10 inches, I guess. So 1 foot. I can definitely give it a lot of noise here, which I probably don't want. That would be kind of one squirrely telephone pole, but just for demonstration purposes there. You can also change the seed, so you can have different characters of the noise. And then by changing the scale, this changes the scale of the noise function. Not the size of the displacement, but the scale of the noise function. So as the noise gets bigger, the deformation gets bigger. As it gets smaller, the deformation gets smaller and smaller along the telephone pole. Now I don't want it, I want it to be a fairly large deformation. I just don't want it to be a perfect straight line. But this is obviously a little extreme. So I'm going to take the displacement down. Now, if we change this noise to fractal, without fractal on, it's a fractal noise. It just has one iteration of the noise. But as you turn on fractal, it's going to give you more iterations. So it's going to be able to reiterate down through the noise function and add detail to it. So 6 iterations probably enough, and you can change the roughness. So if you really wanted a rough-hewn pole or post there, you could get something like that. Now, again, a little too much for a telephone pole, but at the same time, just a tiny bit of perturbation on there, it just takes that edge off.